Hi student. So today we are going to learn about Introduction to Scientific Investigation, Chapter 1. Chapter 1 and yep, here we are again. So in Chapter 1 is about scientific investigation. Means it's about before we do experiment, we got hypothesis, we got variables, we got procedure, and we got the conclusion. That is the science, right? Something that can be experiment, we call it science. If something cannot be experiment or we cannot test it or to know it as a fact, then how do you want to say it's a science? I mean, like story like Jews, Thor, Avengers, that's not science. That's just fiction because you don't see it in the real life. You cannot test it. You cannot experiment it. So these are some of the exercise. So let's look at this exercise. So let's look at a few questions. I mean, for chapter 1, I think it's easy. For chapter 1 now, the first exam is sometimes somewhat easy. Only as you go to learn further, it will be difficult as it progresses. Science is a discipline that involves systematic observation. Correct or not? There must be a systematic observation in science. We can see, we can observe, we can study about the phenomena of nature. Name of the nature of phenomena. So A, B, C, very easy. So this one will be very easy. The number one will be the earthquake. Earthquake is here. So I will just draw this line easier for me so I don't need to copy. This one will be development of human. And this one will be the evaporation of water. Yeah. Number two, fill in the blank and explain how science solve the problem in life. So science can help us solve many things, correct or not? In terms of cooking, infrastructure, your phone, digital, Facebook, everything. All of this need science. Traveling from one place to another place, dot, 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 dot. So traveling from another place faster and save time. This is a revolution. Now our revolution is IT revolution, correct or not? Because it's now everything is talking about. Last time there's a part where revolution like the mechanical revolution, the warp engine, the car engine that started from British. Almost all the revolution start from there during that time at British. So it helped them to create the ship, steamship. Also, that is one of the reason war started. Because last time they cannot start war because they need to use the ship that need to be blown by the wind, and you need to wait for the wind. And it's not easy to start war if you need to wait for the wind. And after they have steam engine, then they start to travel to Malaysia and Malacca. They fight, Pulau Pinang they fight, at Johor, Singapore they fight because they have the steam engine from British or from the Holland to Tanah Melayu, we call it. The discovery of to treat illness and prevent infectious disease from what is the answer? Okay, so this one, the discovery of medicine to treat illness and prevent infectious disease from spreading. But even that now, MCO, coronavirus, we are still looking for the medicine. We are not looking for the medicine, we are looking for the vaccine. It's less superior than medicine. Vaccine is before you get the disease, you put something into your mouth plug, your body to stimulate the growth of antibody to prevent the disease. For if virus, you need to find antiviral, and it is really, really, really difficult. It's not like bacteria. So if you're sick by bacteria, the doctor can prescribe antibiotics. But now, because this is a virus, so you need to use antiviral, which is really not easy to make. And don't want to talk about the medicine. We are talking about the vaccine actually to prevent it. So this one, circle on at the apparatus below that measure the volume of liquid. So here say apparatus. Sometimes in the science you can see apparatus, and sometimes you can see it as called okay, so apparatus. So apparatus is something that we use and we can keep reuse. And another one, what is the name already? It's bahan. I forget what's the English name called. It's like a material that you use it and then it will finish. But for apparatus, you use it after you wash, you can use it again. You wash and you can use it again, and you wash and you can use it again. So this is apparatus. All of this is a apparatus, correct or not? Because apparatus, this one you need to know the name. Because exam might ask, they will give you picture and then they will draw a box, fill in the box. So this one you need to know. This one you know, this conical flask, this is the burette. Each of these things is different. Let's see what he wants to do. Fatima wants to carry out experiment to separate mixture of water and sand. State one apparatus that Fatima needs. So, beaker, the main function of beaker is to what? To contain the liquid, correct or not? You want to put liquid in and it's easy for you to pour. But of course, we can see here, beaker also you can use to measure the liquid, but that is not the main function. Because if you want to say about measuring cylinder is the correct choice, because this one is more accurate, 比较准啊. Of course you can use this one, but it is not accurate. But for doing experiment to just put the liquid, you use this one, because this liquid is easy to put. This one is harder to put, correct or not? And then we have conical flask. Sometimes conical flask has this, so you also can use it as to measure. But what is the purpose of conical flask? Okay, it depends on what experiment you want to do. Okay, sometimes because the experiment you want to collect the gas, you want to collect the bubble, so you need to use the cork and you make sure you channel it out and you put something to block it here, and you can collect the bubble, correct or not? If you want to use beaker, then how to collect the gas? You can't collect the gas. Burette is also to measure the liquid. We also want to use it to measure the liquid, but for burette, it is for, so what is the difference between measuring cylinder and burette? Measuring cylinder is accurate, but burette is even more accurate. Why? Because we can see from the apparatus, this thing is big, fat. This one is so-so, not that accurate. This one is more accurate. This is even more accurate because since it's thin, the diameter is small, so the liquid they put inside, they can really measure to the precise amount. And you can see here there is a tab, so you can open or close the tab. So this is more accurate. So it depends on what thing that you want to do and what experiment that you are conducting. Let's look at this question. Fatima wants to carry out an experiment to separate a mixture, water and sand. Let's highlight this question so we answer the question. There is water and sand. State one apparatus for Fatima to complete this function. Okay, the apparatus is not in the picture. You need to think yourself. So, what is it? So, the apparatus that you want to use is filter funnel. The function is to separate insoluble liquid from the mixture. Insoluble liquid means like sand and water that cannot mix. You want to separate also. So, what is a filter funnel? Okay, so this is the example of a filter funnel. Correct or not? You want to put a filter funnel, and then you put a filter paper up here, correct or not? Still remember? I think this one you study at statistics, right? Then you put you also need to use a beaker so that you can collect the liquid down here. So the sand will start in here, the liquid will go into the filter funnel. Okay, so this thing is called filter funnel to separate the insoluble solid from the mixture. Tick correct the statement below. Which is correct and which is wrong? Uranium is a radioactive substance that can cause cancer. So this is correct or wrong? Okay, so if you don't know, you need to search Google, okay? So uranium is a radioactive substance that cause cancer. Yes. In case you don't know what is uranium, they use uranium to make energy and they use uranium to do bomb atom in Japan. Japan people die of nuclear in Hiroshima and Nagasaki. And it is disastrous and because it's a bomb, and not only this bomb is a bomb, it's a radioactive bomb and it really causes cancer and a lot of people in Japan suffer. But during that time, the America, they hide this news until later part. I think after a few 10-20 years, they release it and they say they won't use it again because it makes the people really suffer from it. Okay, so this one, chloroform and ammonia are flammable chemical. True or false? So this is false. Okay, false. Chloroform, they used to a lot of function. If you see in the movie, they take something in the handkerchief and then they put and then then the person fall asleep. That's chloroform. Supposed to be used in the hospital, right? The hospital that give you something for you to smell, they put on your nose and then you start to fall asleep so that the doctor can do operation on you. That's a function of chloroform. Also to stick plastic. But because this thing is dangerous, because it is for kidnapper to use, right, to cover other people's nose. So this thing is banned. If you want to buy this thing, you need to have license. If you're a pharmacy or hospital or factory, then you can buy. I got the car factory, they can buy chloroform because they want to stick the plastic plate. And ammonia, this one is subjective already because ammonia can be referring to many things and some ammonia is flammable. But chloroform is not. So just okay. Mercury is a poisonous and toxic substance. So this will be correct. Mercury is poisonous because it can go into your hand. Let's say you put mercury in your hand, it will dissolve from your hand skin to your blood. So if you put water, the water won't go into your skin, so it's alright. But if you put mercury on your hand, the mercury will go into your blood and it will start to poison your body. That's why it's dangerous. The diagram below shows the situation that occur in the laboratory. What action will be taken for this situation? So, yeah, if you saw this thing happen in your school, what are you going to do? So we can say for this one, it must report to the teacher. Almost for everything, right, that has been done wrong, the first thing you can do and must do is to report to the teacher so that the teacher know what the teacher know what to do. How about for B? Or we can say rinse with plenty of water. Rinse with plenty of water. Of course, this one also you need to report to the teacher, okay? And one of the way is, let's say you smell things or your eye being injured, don't rub it, help me. So what you need to do is take the water and splash your eye so that it will rinse the chemical away. Even acid or what, correct or not? If I put this thing very acidic, this thing is very dangerous because this acid. But if I put a lot of water and mix the acid with water, it might not be that dangerous. Maybe you can even start to drink it if you put a lot of water into it, correct or not? Let's say if this thing is really acid, but I put in a very big tanki, a big water tank, and you start to wash your hand, probably nothing will happen because the water already dilute the acid. So of course this water also is true. Physical quantity are defined by physical that can be calculated. Match the SI standard international unit that can be used to measure the physical quantity of the object below. So this one, what we want to measure it. So for this one is temperature, we know. How about for the second? So for this one will be mass, correct? Very easy, right? Because it is chapter 1, don't worry. As the time pass, you will do more difficult question. Now it's an easy question for you to do. So continue on. Oh, this one you need to memorize. 1 million, 0.0001, 1,000, and 0.00001. Circle the prefix. So for number 1 million, what do we call it? So for this one, 1 million, it will be mega. Means big, right? Mega. Mega mole, right? Mega. 0.001, the answer is milli. How do I know it's milli? Just in case you forget in exam, we know that the SI unit for length is meter, correct or not? 1 meter is the SI unit. If I want to change the 1 meter to cm, it will be 0.01, correct or not? Because I times 100, I get back 1 meter. And from cm, if I want to go to mm, it will be 0.001. Okay, so 1 meter to cm to mm. 1,000, what is it? Correct. So this answer is kilo. Correct or not? 1 kilogram means there are 1,000 of gram. So, or 1 kilometer means there are 1,000 of meter. 0.00001. So this one will be micro. So let's put here micro. Means very small, right? Microchip. Microorganism. Microscope. Micro means very small. 0.00001 times 10 power of negative 6. Okay, I mean I can press in the calculator like this, I still get back the same answer. So usually for like, I'll just put here 1 times 10 power of negative 6. Correct or not? You learn this in maths. I think you are going to learn this in maths. Like the speed of light and so on, the length of the universe. They use light year lah, but the reason we use this because it's easier to see rather than 0.00000000001. This times 10 to the power of 1. Continue on. Oh, this is a bit unclear, but hopefully we can still read it. Oh, how come I didn't see that this is unclear? Abu measure the thickness of 10 pieces of paper. So this is 10 pieces of paper as shown in the diagram. So without paper, we want to look whether there are error or not, zero error. So we can see there's a zero error here, correct or not? Because it's not starting with 0. I can see from here, the zero error is Here is 50. Here is 45. Here is 40. So the zero error, because it doesn't start with 0. So I can count here is, you need to count from 50, right? Or 0. So we calculate 1, 2, 3, 4, 5, 6. So there's a difference of 0.06. So if I get the reading, I need to minus 0.06. Actually, you need to plus, but the formula is minus the 0 error. So minus minus become plus. Correct or not? So that after you get your reading, you need to plus the 0 error. So after you get the reading from here, you need to minus 0.06 because this is extra. Even if you put 0 paper, there's already extra. So with this, we call this as 0 error. It's not your eye error. We call it, could be parallax error. This is called 0 error. The measuring is not starting from 0, either more or less. Then after that, in this picture, can I move to the right? Okay. In this picture, how to read this reading? So it starts from 0 again. This is 5. 3, 3.5. This is 4. It must be 4 point something. 4 plus something. Correct or not? What are these two-digit number? And if you don't know, then it's okay lah. Because this is actually Form 4 Chapter 1 Physics. And they change it to, Form 1 Chapter 1. That's why all of the students get wrong. But this is, you learn this at physics, you know, it's not even science, it's physics Form 4 Chapter 1. Okay, 4.1, let's look at this one. How to count this one? So, 4, it must be 4 point something. So, here is 45, 46, 47, 48, 49. So here is 0. So it's supposed to be 4.49. We follow this line. 4.49. Here is 49. Okay? So now we fix this problem. We can see here the reading of the 0 error is 0.06. And for this is 4.49. But of course, if you cannot read this, means you cannot do this question already. Name the apparatus that was used in this activity. Lusanti, what is this apparatus? So this is the answer, micrometer, screw, gauge. Because they are talking about apparatus, means what is this thing? This thing is called micrometer, screw, gauge, if you still remember. Name an error for the apparatus and how the error. So for this question, there are two questions. The first question is name an error. Second, how the error is detected. So what is the name of this error? Okay, so this is a 0 error and it is determined when the micrometer is clamped, or you want to say closed, because even you close it is supposed to be 0.00. But from here is 0, but it is not 0.00. It's actually 0.06. Okay, 0.06. Actually, not 0.06, like it's actually 0.44. But I cannot do like I get this number 4.49, then I minus 0.44, and then I won't get it correct. Because I supposed to minus 0.06 because the difference is 0.06 extra of 0.06. Okay, so calculate the thickness of the paper. So, yep. So this one I will do. So, of a piece of paper. So first, we want to minus the this one minus this one, correct or not? So we want to use the zero error is negative 0.06, correct or not? So the reading of the micrometer screw gauge is 4.49. You get already 4.49. So 4.49 minus 0.06. So you will get 4.55 mm. Around here you will get like 2 marks. But this is not the final answer because the question said a piece. A means one, singular noun, correct or not? A book, you cannot say a books, right? A book means one. A piece of paper means one. So let's look at the question. The question said 10 pieces of paper. So we need to use 4.55 millimeter divided by 10. So just do this. 4.55 divided by 10. So you move one up, move one value up, it becomes 0.455 mm. Or if you want to round it off, you can say 0.46 mm. So this will be the final answer. Okay, no problem. Moving on. Okay, so this is a K-bar question. I think you guys know already what they mean by K-bar, right? Like you need to think the answer. The answer might not be in the textbook, but you need to think. What's this name? Alia was given two measuring tool which are ruler and vernier caliper. Still remember the vernier caliper? Like this. Yep. Measuring the thickness of a book. Which of the tools should be used by Alia? Explain. So again, there are two questions. The first question is which tool? Second thing, explain. So the question asks, Alia has a tool, a ruler and vernier caliper. This is vernier caliper that you can adjust like in the ruler. So the question says which one you want to use. You want to use a ruler or vernier caliper. So of course there are ruler and vernier caliper. The answer will be vernier caliper. Of course you can use ruler. Assuming this is a ruler, I can measure it. And I still can get the length. But it is not that accurate. This one is more accurate because the line is fit on the book and it can measure up to 0.1 mm. Micro screw gauge can measure 0.01 and 0.001, but for vernier caliper can measure up to 0.1 mm. So this one can measure up to 0.1 mm. Of course, just now we already did. Screw gauge can measure up to 0.01. So let's write down the answer. So we can say that vernier caliper because what? Because it can measure up to 0.01 mm. Okay, very good. Let's move on. The diagram below shows two eggs of the same size that put into the solution. This one you can do your experiment at home. If you put an egg in a beaker or in a cup, then the egg will sink. If you take the salt and put in the water, stir it, and the egg will float. So we can do this experiment at home. You can do it. But after you do, you must eat the egg already. Like you cannot eat. I mean, you know, right? After the egg got water, it cannot last long. It will spoil very fast. So after you do this, you need to and late dinner you need to eat it already, or breakfast or whatever thing. Give inference of the egg position in beaker A and B. So inference, what is inference? Before we do, what is inference? So an inference is early conclusion that you made in an experiment. Of what experiment we have hypothesis, we have conclusion. Inference also similar to conclusion, but it is the conclusion based on the evidence you see in the experiment. So, or what thing that you know actually that affect it. So maybe for this one, we can say that an egg emerges because an egg is more dense than water pipe. Correct or not? So maybe I can say the egg is submerged because submerged or sink because it is denser than water. And for this one, of course, you can say the egg will float because it is less dense than the sea or salt water. Sorry, you cannot see it. The egg will float because it is less than salt water. It's an early conclusion that can be based from the experiment that you see at here. Okay, so that's it for this video. Thank you very much. I hope to see you in next video. Thank you.